So I'm going to go through the test review fairly quickly, but if you need to pause, go ahead and pause so you can adjust or write down what you need to. Alright, for number 1, you're supposed to write a rule for the following sequence. Remember that to find the common ratio, you have to take the second and divide it by the first, the third divided by the second, and as long as those numbers are consistent, which in this case 10 divided by 2 is 5, 50 divided by 10 is 5, so forth. You can write the rule, and the rule is a sub n equals a sub 1, which a sub 1 is the first number, times the common ratio raised to the n minus 1. And then we're going to sum up. That's what the s sub 20 is. You're going to sum up the first 20 terms, which we use the sum up rule for. And so that should be the setup of your summing up rule. And then if you punch that out correctly, you should get 4.77 times 10 to the 5th. For number 2, it's similar, except the information is given to you a little bit differently. You're still given a sub 1. A sub 1 is the initial value, so that was 2057. And then you're given the rate of increase, which is 6%. Now that's 6% of already 100%. So that's why I have 1.06 as my rate, or my ratio, because you're increasing by 6% off of 100%. And then we have our exponent n minus 1. And then the last sentence here, find the total tuition someone would pay if they attended college. That's summing up the total for 5 years. So we use the summing up rule again, which, if you do that correctly, you would get almost $12,000. Okay, for number 3, you need to set up each into that a sub n rule, where 10 is the a sub n value when n is 3. So we plug 10 in for a sub n, 3 in for n. Over here 80 and 8 for n. And then I divided both sides here by r squared, and here by r to the 7th. And then you take both of these, since they're both equal to a sub 1, you can set them equal to each other, and then cross multiply. Here I divided by r squared to get r to the 5th, and divided by 10 to get 8. And I took the 5th root of both sides. Then I took this 1.52 and to find a sub 1, I went back to this equation and took 10 and divided by 1.52 squared. That got me 4.33. And then it's just putting it into the rule at that point. Okay, go ahead and flip. For number 4, you have a normal distribution with a mean of 45 and a standard deviation of 4. So put 45 in the middle and added and subtracted 4 on either side. And we're supposed to find the probability that the randomly selected x value from the distribution is in that given interval. Now, you need to show all work, so I do expect to see that you're adding and subtracting the decimals to give me the final answer. So, between 41 and 57 would be this space here. So I took 0.34 plus 0.34 plus 0.135 plus 0.0235, and that got me 0.8385, which is 83.85%. And then at most 49, then you're going from all the way over there to 49, so 0.0015, and then adding up both of those, and you get 0.84, which is 84%. Remember, at most means it can't be over that, but it's everything under that. Number 5, same kind of deal with a mean and a standard deviation. At least 50 means that's the lowest value, so it's going to be 50 on up, and so you'll see that that's what I added up here to get 97.5%. And then because it's 3 randomly selected x values, we raise that to the 3rd power to represent that we're multiplying it by itself 3 times. You get that decimal, which turns out to be 92.69%. So if you pick 3, there's an almost 93% chance all 3 would be at least 50. And then for 6, you have 2 different girls, 2 different normal distributions. And because in both, when you figure out the markers, the scores that they get, 30 and 610, aren't a marker. So when that happens, you have to use z-scores. So we figured out the z-score for Anne is 1.22, and the z-score for Lisa is 2.38. Then I used my chart to find these values. And then, so this is the probability, 88.88% that Anne scored in comparison to everybody else, that's where she scored. And then here, that's where Lisa scored in comparison to everybody else. So Lisa scored better on her college entrance exam. And the reasoning is she was in a higher percentage of passing the exam, because that probability means she's 99.13% above everybody else. Okay. For D1, this is where you might need to pause and just kind of read through, because I was pretty explained in writing too. So, because this is kind of how I want to see your answers on Monday. Just a review over what 4 samples there are and what they mean. Then for D1 here, to describe a method of selecting an unbiased random sample. This is one I came up with. Yours might be fine too, as long as it's a way to randomly pick. So I said assign a number to each student and then use the random number generator to select 250 random students. For number 9, this is a systematic sample because they have a rule. They ask every 3rd customer. But it's also biased because they're not asking people on the weekend, which would miss a lot of people that have to work. So you could say it's biased. Number 10, this is a convenient sample because they're going to the nearest grocery store, but it's biased because they're not reaching every group that would be affected. Changing the school year to all year definitely would affect everybody in the community, and they're only going to one place, so it will be biased. For 11, give a detailed example of a biased self-selected survey. So this is you coming up with one, where in the example of whatever survey you're doing, they are volunteering, and then you've made some connection between those people and what you're surveying them about so that it is biased. And if you want me to look at that one tomorrow, I will. If you want me to look at your specific example. Number 12, margin of error. You surveyed 181 people, so that goes into the 1 over square root of n. Goes in for n. Punch out, you get 0.074, which is 7.4%. And then to find the interval that the actual percentage would lie in, we take 7.4 and add and subtract it from 23. So that's the range of actual percentages that it could be. For number 13, to find the percentage the sample voted for candidate A, we took 230 and 5 and divided it by 500 to get 47%. That means in candidate B, if you take that 47 away from 100%, 53% of people voted for candidate B. Margin of error, they only surveyed 500 people, so that goes in for n, so you have 4.4% margin of error, so we add and subtract that from both sides here. And then for C, based on your intervals, can you be confident that candidate B won? You can be mostly confident, but there is a 2.8% overlap, so I can't be completely confident. And by that, I mean the low end of B and the high end of A cross over 2.8%. So you can't confidently say that candidate B won, but 2.8 is a pretty small percentage to overlap. Okay, for 14, in a survey conducted of high school students, 34% claim to have texted during the exam. So we're looking for the sample size. Oh, and I did that wrong because I put in 0.34 instead of the margin of error. Whoopsie. Okay, let's try that again. So that should be 0.07. So this is 07. And then 1 divided by 0.07 should be 70, but let's make sure. Oh, no. 14.285. And then if I square that, you end up getting 204 students. So 204. And then we'd have to take 0.34 and multiply it by 204 to find out for part B, or for the second part of that, how many actually of that 204 said they would text, and 70 students that turns out to be. So it's the margin of error that you set equal to 1 over square root of n to solve for the sample size. Okay, for D3, for 15, this is biased, and actually this is kind of the same reason for both. They're both biased because in the first case, it's assumed that the respondent knows what arsenic is and that it could pose a health problem. Because if they don't know what arsenic is, and then you tell or call it a health problem, nobody wants a health problem around, so of course they want it addressed. But that's not, that's going to introduce bias there just by calling it a health problem without making sure they know what arsenic is. So the fix would be to put a research-based paragraph about arsenic at top first, so you make sure everybody has the same baseline information. And then the second one, kind of the same deal. It's not enough information because you don't explain anything about the budget cuts. So provide an outline of budget cuts for the respondent to look at before answering the question. Number 16. This is an example of an observational study because the person has no treatment. There's also no way that you can control what else would affect the non-smoker and smoker's health. So you just have to observe maybe the effects of nicotine in those 200 people. And for the second one, this is an experiment. There's definitely a treatment, which is adding in shea butter into their hair conditioner. And there's a treatment group, people who are using the new hair conditioner, and a control group, the people that are using the old hair conditioner. Okay, for 17A, I realized that this was one we already talked about, so in the second one, this would be an experiment, and this is just one way that you could do the experiment. Buy one type of flashlight, because remember with an experiment you need everything the same except for one variable. We want the one variable to be the battery that you use. So buy one type of flashlight, maybe all the same brand, and I said just buy 10. Put one type of battery in 5, and then the other type in the others. Turn them all on and leave them on, and monitor the times they turn off. Would be the step 2. And for 18, this has to be an observational study because you have no control over when the people actually get up, and you can't regulate their other morning routines. So it says, if it's not explained, why not? That would be the why not. And discuss whether the conclusions drawn from the study are valid. You could argue that they are somewhat valid, but not completely, because there's so many other things that go into not getting into accidents. So if the early risers, maybe they get up early so they can have a cup of coffee, and they breathe a little bit, and they're just more awake by the time they get out of the house, and maybe that's why. Maybe it's the type of job they have. Yeah, there's lots of different reasons why they could not get in more accidents than other people. So you could argue that no, that you can't really trust them, but it would make sense that if they got up early and they had more time in the morning to get ready, that maybe they're a better driver because they're more awake. Alright, that finishes up your test review video.